Hello children, in the previous section we have done about the male reproductive wall, stamen, and also we have done how the pollen grain was formed, whole process of microsporogenesis. Now we will start with the female essential wall, and it is called as a pistil or a megasporophyll. Megasporophyll, fill word comes from a leaf, and that means this is a modified leaf structure which will possess a megaspore. Pistil can be of two types. One is called as monocarpellary or a polycarpellary. Monocarpellary means if the pistil is made up of only one carpel, then it is called as a monocarpellary condition. But if the pistil is formed of many carpels, then it is called as polycarpellary. Many pistils are there, and polycarpellary therefore is of two types. One is called as syncarpous condition, another is called as apocarpous condition. If the carpels are fused to form a one pistil, then the condition is called to be syncarpous. An example is called as a papaver. Apocarpous. Apo means free. If the carpels are free, they are not united to form one pistil, they are separate, then it is called as a apocarpous condition. And few examples are Michelia, Rose, Ranunculus, etc. Now, if we talk about a carpel can have a one ovule or it can also have many ovules. Carpel can have one ovule or it can have many ovules. If the carpel has one ovule will form into a seed. That means a fruit which is having one seed will be termed as having a one ovule. For example, we have mango, peach, lychee. These are the examples of the fruits which are having one ovule. Many ovules, examples are apple. We can have apple, papaya, etc. Many examples you can know. Next, in the next section, we will discuss about ovule. So, ovule is also called as megasporangium. Sporangium is a sac-like structure which consists of a megaspore. Very first of all, we will discuss about the structure of an ovule. Then we will discuss how this megaspore and that will be converted into an embryo sac. Ovule. We have seen many fruits. We have cut many fruits and we have seen ovules, the seed into it. The ovule is attached with placenta. This is the placenta. The ovule structure is attached with the placenta with help of a stalk-like structure called funicle. This funicle is when attached to the ovule. That is called as hilum. That means it is a place where the ovule is attached to the funicle. That is called as a hilum. Just near the hilum, we have this micropyle end. How this is formed? This is the outer integument. This is the inner integument, which is the covering of the ovule. Ovule can have one integument, it can have two integument, it can have three integuments, not more than three. One, the outer integument and the inner integument is there. Now we have this structure called where there is an opening between these integuments. This structure, this point is called as a micropyle. Micropyle is a very small opening from where the pollen tube comes and enters into the embryo sac so that two male gametes can come and fertilize here with the egg. To the inside of the integuments, we have this nucellus. Nucellus is highly nutritious. It just gives nutrition to the growing embryo sac. And now we have one more structure, that is extension of a funicle, which is called as a raphe. This is called as a raphe, which is regarded as a backbone of a ovule. This part is called as a chelazal end, and this part, this one part is called as a chelaza. There is a chelazal end, the micropyle and the funicle. When they lie in the same place, that type of ovule is called as a anatropous ovule. We will discuss the types of ovule in the next section, but the most commonly found, that is given in your NCERT, is also, that is the anatropous ovule. That means the funicle, the micropyle and the chelaza, they lie in the same plane, and this type of ovule is inverted type. This is called as a anatropous ovule. We have discussed about the raphe, we have discussed about the nucellus, chelaza, micropyle, funicle, hilum. Then we have discussed about the outer integument and the inner integument. All these structures are the part of a flower. They have not participated in meiosis. They have not undergone any division like that. Therefore, these all structures are hence diploid. This we have to remember. Therefore, inner integument, outer integument, then we have the micropyle, funicle, nucellus, raphe, even chelaza. These are all the diploid structures. These are all diploid structures. But here inside the nucellus, we have an embryo sac. Embryo sac is a resultant of meiosis that we will discuss later in the next section, that how this embryo sac forms, how the megasporogenesis occurs. These are always a resultant of a meiosis, therefore they are always the haploid structure. This embryo sacs consist of 3 antipodals, which are all haploid. We have 2 polar nuclei in the center of the embryo sac. These are also, they are 2 in number. They are also haploid. I am writing 2 times because we have 2 polar nuclei. We have an egg. Egg is always a haploid structure here. We have cynogens also. They are 2 in number. They are also haploid. We have discussed in +1 that egg and cynogens, these both together are called as a egg apparatus. Only egg, also called as oosphere, plus cynogens are called as a egg apparatus. If I draw the enlarged structure of cynogens here, this is a cynogen. You can see here the finger-like projections. This is cynogen. This is a nucleus of a cynogen. This is called as a filiform apparatus. This filiform apparatus is an irregular structure which guides the entry of a pollen tube. We will discuss all these structures one by one now in details, and we will also discuss the megasporogenesis in the next sections. Thank you.